Yo, what up, everybody? Welcome to a coding stream. We haven't done one of these in a little bit. We're gonna be playing the Heartbound OST because Pirate Software has made it clear you won't get copyrighted for using it. So that's pretty cool. Hi, Gore. What about Fallout? How did last stream end? I murdered Dave. I think that was the last thing I did. Yes, Dave has been removed. I want to adjust this a little bit so you guys can see this a little bit better. YouTube didn't give notification? Of course not. They hate me, dude. Okay, how about this? That'll work. That'll work. I'm gonna cut off the assignment slightly, but I actually want you guys to see what I'm doing. So this is Boot.Dev. For anyone who doesn't know, it is a coding website that it just teaches you coding. So this is not the very start of it. I've already done some of this. And we're just gonna complete some of the assignments they have. You know? So, now that we know how to store and change the value of variables, let's do some math. Here are some examples of common mathematical operators in Python syntax. Sum equals a plus b, difference equals a minus b, product equals a times b, quotient equals a divided by b. Typical math equations. This will also act as like a coding tutorial. Like, you guys can learn with me. So that's pretty cool. Create a new variable called armored health on line 4 and set it equal to player health times armor multiplier. It's time for a billion else if statements. Oh yeah. So we're making a new variable, armored health. Armored health equals player health times armor multiplier. Run. Submit. Yay! Do not the else if. Oh, else if statements are really fun. Why don't you want to do else if statements? Let's do some more math. Said no one ever. Creating negative numbers in Python works the way you'd probably expect. Just add a minus sign in front of the number. My negative number equals -1. When our hero walks through poison, their health should be reduced. Right now the hero is gaining 10 health instead of losing 10 health. Change the poison damage variable to be negative. Boom. Run. Yay. Fun fact, computers can do math on really big numbers very quickly. As if anybody didn't know that already. Comments don't run like code. They are ignored by the computer. Comments are useful for adding reminders or explaining what a piece of code does in plain English. Singular line comment. Speed is a variable describing how fast your player moves. Multi-line comments, aka doc strings. You use triple quotes to start and end multi-line comments as well. It's useful if you don't want to add the pound sign to the start of each line when writing paragraphs of comments. Is that just called the pound sign, or does it have an actual name? I don't know. I know people call it the hashtag now, but line number 1 in the code is meant to be a comment, but the developer forgot the right syntax. Fix the bug by commenting out the first line of code. Skimitar. Alright. These are very simple, of course. This is the very beginning of what the course is, so none of these are going to get too complex at the moment. Variable names can't have spaces. They're continuous strings of characters. In Python, you should snake underscore case, which, when creating variable names, becomes the rule of thumb for the language. By the way of comparison, camel case is where the beginning of each new word, except the first, is capitalized. That camel case is what we used in the course I was doing for a while. It's very weird, but now I have accidentally used camel case outside of coding at points. Casing examples. No casing, pure insanity. Some variable here. Camel case, snake case. I prefer snake case. This is just so much more readable than either of these. This is better than no casing, but honestly, that's much better. Which is valid camel case? That one. Which is valid snake case? Thank you. Okay, basic variable types. In Python, there are several basic data types. Strings are raw text encoding speak. They are called strings because they are a list of characters strung together. Strings are declared in Python by using single quotes or double quotes. That said, for consistency's sake, we prefer double quotes. That's one of the things they tell you in coding. Even though there's multiple ways to do it whichever way you want, but just make sure it's consistent. Like if you use double quotes once, don't use double quotes and then use single quotes at a different point. Use double quotes through the entire document. Numbers aren't surrounded by quotes when created, but they can have decimals and negative signs. And you don't. Float is a number with a decimal. A boolean. Not bouillon. So nobody's making soup up in here. Original joke, I know. Is a type that can only have one of two values. True or false? As you may have heard, computers really only use ones and zeros. These ones and zeros are just boolean values. Fix the bugs in the code to move on. Player health should be an integer, and player has magic should be a boolean. A bouillon. So we delete the quotes around that. We delete the quotes around both of them. This is more, rather than starting from scratch, this is learning how to edit code. At the moment, at least. I don't know what the deal is. It's off screen, because I moved it off screen. But you get, like, badges and achievements. Boot.Dev really runs things like it's like a video game, pretty much. I do like that about this. You can create a string with dynamic values by using f-strings in Python. It's beautiful syntax that I wish more programming languages used. So, print f, you have num bananas. You have 10 bananas. The opening quotes must be preceded by an f. Any variables with curly brackets have their values interpolated into the string. Fix the bug on line 7. Use an f string to inject dynamic values into the string. Replace name with the value of name variable. Replace race with the value of the race variable. Replace age with the value of the age variable. Okay, first of all, we need the f. Brackets. 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 Nice and easy. Oh, because they're all... Why would you make them uppercase? Growl is a dwarf who is 37 years old. Cool. All variables have a value. We can declare an empty variable by setting it to none. The value of empty in this instance is none until we use the assignment operator equals to give it a value. Note that the none type is not the same as a string with a value of none. Declare a variable named enemy and set it to none. Don't change the print function. Enemy equals none. I immediately screwed it up. Or, wait, was I supposed to? Oh, I was supposed to do none type. Cool. As we mentioned in the last exercise, the none keyword is used to define empty or null variable or object. In Python, the none keyword is an object, which we'll cover later, and the data type is the class non-type. Why might you use a none value? I don't want to watch another YouTube video. That'd be kind of meta to watch a video during stream. So, a none value. To create bugs. Python is dynamically typed. All this means is you can store any type and that type can change. For example, if I make a number variable, I can later change that variable to a string. This is valid. Speed 5, speed 5. Just because you can't doesn't mean you should. You can doesn't mean you should. In almost all circumstances, it's a bad idea to change the type of the variable. The proper thing to do is to just create a new one. For example, speed description. Yep. What if it weren't dynamically typed? Languages that aren't dynamically typed are typically statically typed, such as Go, which you'll learn in a later course. In a statically typed language, if you try to assign a value to the variable of the wrong type... Let me try that sentence again. If you try to assign a value to a variable of the wrong type, an error would crash the program. If Python were statically typed, the first example from before would crash on the second line, speed equals 5. The computer would give an error along the lines of you can't assign a string value 5 to the number variable speed. On Tuesdays. Yes, you can only change the type of a variable on Tuesdays. You heard it here first, folks. Python likes dynamic. Math with strings! Yay! Does that mean, like, violin strings? Or guitar strings? Most of the math operators we went over earlier don't work with strings, aside from the multiplication and addition operators. When working with strings, the addition operator performs concatenation. Sure, I hope I said that right. Concatenation is a fancy word that means the joining of two strings. You should prefer string interpolation with F strings over concatenation. first name Lane, last name Wagner, full name equals first name plus last name, print full name, Prince Lane Wagner. Full name now holds the value Lane Wagner. Notice the extra space at the end of the of Lane in the first name variable. That extra space there to separate the words in the final result, Lane Wagner. We have a second player in our game. We need to tell each of our players how much health they have left. Edit line 9 to print players 1 health, 1200 health, using a string concatenation in the variables provided. And edit line 10 to print players 2 health, you have 1100 health in the same way. So... yeah, it's just print. Do I have to do an F string? Oh, I get it. It's saying you should prefer it with F strings, but it wants concatenation this time. So you're doing... Nope. Nope. Hit the right keys, please. Will this work? Oh, well, of course, I didn't do the second part. No, I didn't. Hit the right things, idiot. Cool. Alright, I don't know why that happened. Multivariable declaration. We can save space when creating many new variables by declaring them on the same line. Sword name, sword damage, sword length equals Excalibur 10, 200. Which is the same as this, it's just condensing the line. Any number of variables can be declared on the same line, and variables declared on the same line should be related to one another in some way so that the code remains easy to understand. We call code that's easy to understand clean code. No limit. Codes that are easy to read and understand. This is an optional challenge. You can skip to the next chapter if you want. Let's see what it is. Email output. An e-commerce store has configured an automated receipt, but can't figure out how to print the email message in the correct order. Add some print statements to the end of the code to get the expected output. Thank you for shopping with us. Your total today was $25. Please consider filling out our customer survey. Make sure you only use the provided variables. Don't use any new raw strings or numbers. Make sure the output is contained within 3 lines. So, email start, email middle, email end. Print. Thank you for shopping with us. Print. So yeah, we want to do them on different lines. Email middle plus is $sign really necessary to have its own function? Or own variable, rather. Total price. Once again, we print email end. That wasn't too hard. Another optional challenge. Alan's favorite NBA basketball team just played a 7-game series in the playoffs. He needs help writing a program that will calculate the average points scored by his team through the 7 games. Using the score variables, assign the average score of the 7 games to the average score variable. After completing this challenge, don't forget to check out the solution, which is a way to format a line of code when it's too long to fit on screen. Cool. Game 1, Game 2, Game 3, Game 4, Game 5, Game 6, Game 7. Don't touch above the sign. Average score equals... Well, it would be Game 1, 2, 3, 4... Oh, that's report issue. Okay, so obviously the way to solve this is to Game 1, Game 2, Game 3, Game 4, type all of this out. We'll do that. Just Game 1. But I want to see how to condense it. Jume. Of course. Game tree. Game 4. What? Buy a seer stone. I have no idea what that means, but okay. Oh, okay. Yeah, it's just... Oh, yeah, and then divide by 7. Duh. Fair. Annoying that you have to type this all out. Oh, well, at least I don't have to keep mousing over. By 7. Oh, because I didn't put a space there. Yep. Yay! We did it. Tim is working on a program that writes a poem to the console. However, Tim is having trouble getting the poem to print on only 2 lines. Use string concatenation to assign values to the line 1 and line 2 variables correctly. Line 1 should include part 1 and 2. Line 2 should include part 3 and 4. So you just do part 1 plus part 2. Part 1 plus part 2. And then you do part 3 plus part 4. Why are these aren't overly challenging. Why am I in guest mode? Oh, because I don't have a membership. That's fine. We'll stay in guest mode. I'm not going to pay for a membership at the moment. I might in the future, but functions allow us to reuse and organize code. For example, say we've written some code that calculates the area of a circle. Radius 5, area 3.14, times radius. That works! The problem is when we want to calculate the area of more circles, each with its own radius. We can just copy the code and change variable names like this, but we don't want to reuse our code. Why would we want to... But don't we want to reuse our code? Why would we want to repeat our work? What if we wanted to calculate the area of thousands of circles? That's where functions help. Instead, we can define a new function called area of circle using the def keyword. Yeah, that's def. Sick 90s slang. The area of a circle function takes one input and returns one output. Def area of circle, parentheses r, pi 3.14, result equals pi times r, return result. The body of the function is indented and contains the code that will be run when the function is called. The return keyword tells the function to return the value that follows as the output of the function. A function can have more than one return statement. The name of an input is called a parameter. In this case, it is r. The value of the input is called the argument. To call this function, call a function is a fancy phrase just to mean to use a function. We can now pass in any numbers as the argument, in this case 5, for the parameter r, and capture the output into a new variable. Area of a circle. Print area. Yeah, but you get it. It does the thing. The 5 goes in as the input r, the result is calculated, so that comes out. The function is already defined, you can use it again and again, different outputs. So we need to calculate the size of a weapon's attack area. With a 1.0 meter sword, for example, a player can attack in an area of 3.14 square meters around them. You can use the area of the circle function to do that in your calculation. This is what I like about Boot.Dev, is it kind of puts everything in the perspective of a video game. So where a lot of times when you're doing coding and everything's kind of abstract, it can be a little bit harder to understand. But when you put it in the perspective of, oh, okay, I'm making this because I need to calculate the area a sword can swing around me. Okay, that makes it make sense. That's giving it a purpose. It's not just, hey, here's this function. You know, learn how to make this function. This is what a function is. Now make a function. Like, oh, okay. I'll make a function that says how many muffins are in the bakery. Like, that's what I really disliked about the course that I was taking before. Is it was just kind of abstract and annoying. So you can use the area of a circle function, fix the bug on line 13. The spear area variable should be set to the result of calling the area of circle function with the given spear length as input. Why would a spear have the area of a circle? I guess if you're talking about the range you can attack from, you're not like swinging the spear in a circle. It's just how far the spear can reach, and it can reach in any direction around you. So that makes sense. Spear area variable should be set to the result of calling the area of circle function with the given spear length as input. Yeah, so it should be area of circle spear length. Become a member to run? Become a member to submit? Oh, I can't do any more? Well, balls. That sucks. I didn't realize that was the cutoff point. Piss. Well, that's how you would do that. Can I continue? Well, I can't submit anything else. I guess this is the cutoff point when they're like, okay, you can't sample the course any further. You have to pay. Fair enough. Fair enough. I suppose. I just won't submit anything else. We can still learn. Functions are tricky. I wouldn't say that they're hard, but it does take a minute to get used to them. You might find yourself slowing down a bit in this chapter, and if you do, know that that's totally normal. Functions aren't that difficult once you figure them out, honestly, in my personal opinion. Let's break down this function line by line so you can understand every nook and cranny of it like an English muffin. Yeah, we've already read this. Here's a chronological explanation of what happens when the above code is executed. Oh boy, do we really need to read this? Def area of a circle R, area of a circle function is defined for later use, but not called. It accepts a single input named R. Body of the function pi is for now. New variable called radius is created and set to the value of 5. Area circle function is called with radius, in this case 5, as the input. Finally, we jump back to the function definition. We now start. Yeah, we don't need to read this. We know how a function works. This is the same thing. Oh, we should answer the questions though. Which happens first? The function is defined. The function is defined. Of the choices, which step happens last? The value is returned. Because it would go function is defined, function is called, result of pi is calculated, and a value is returned. Why is the function variable called radius outside the function, but r inside the function? Ugh. Because programming is needlessly hard and makes me want to cry sometimes. I need that on a shirt. I need that. Can I get programming is needlessly hard and makes me want to cry sometimes on a shirt? I need that. Only the value of the variable is passed to the function, and the assigned is an assigned new variable called r, because all variables are called r inside functions. It's all variables. I mean, you're just shortening it, right? Like, You do R because R is better than writing out radius every single time. Okay. Functions can have multiple parameters, which is just a fancy name for inputs. For example, the subtract function accepts two parameters, a and b. So you're just doing a minus b. Naming parameters doesn't matter as much as setting their order. The first parameter is the first value that you pass in, the second parameter is the second value you pass in, and so on. In this example, the subtract function is called as a equals 5 and b equals 3, 2. This function accepts four parameters: name, age, height, and weight. Yeah, your name is, you are this old, your height, and weight. It can be called like this: intro equals create introduction, John 30, 1.8, 80. Your name is John, you are 30 years old, you are 1.8 meters tall and weigh 80 kilograms. I was gonna say, I did not realize it was in kilograms instead of pounds. I was like, if you're 30 and you weigh 80 pounds, you have some things to be concerned about. We need to calculate the total damage from a triple attack combo. Complete the triple attack function that takes three numbers as its parameters and returns the sum. So it would be damage 1, damage 2, and damage 3 equals yeah? This is the tough part about not being able to do this. So well, okay, here's the thing. You don't really... This is what's confusing me about this right here. Because it's got these. Why would you print all of this? Why would you not bake it into this function to say... first part, or first, like, /1. So why would you not do /1, getting damage for... damage 1, damage 2, or damage 1. I mean, or just... Why is it using /1? Oh, okay. This is throwing me off a little bit. Because I feel like this would not be how you format this, especially with the way it's showing you how to make functions here. So why would you not write def triple attack first getting damage for /1, /2, and /3, or damage 1, damage 2, damage 3. Print, or well, not print, but now next line, do this. Damage 1, damage 2, damage 3, points of damage dealt. I don't like that one. You've probably noticed that a variable needs to be declared before it's used. For example, the following doesn't work. Print my name. My name equals Wagner. Yeah, because things go in order of the code written. Lines of code execute in order from top to bottom. That's what I mean. It starts at the top and goes down, not in the order of written. Whatever. You knew what I meant. So a variable needs to be created before it can be used. That means that if you define a function, you cannot call that function until after the definition. The main function is a convention used in many programming languages to specify the entry point of an application. By defining a single main function and only calling main at the end of the program, the entire program, we ensure that all of our functions are defined before they're called. There is a bug in our program. Fix it. You just reverse these two. You put that up at the top. Because you're trying to call main right here. But you can't call it before it's defined. All functions must be defined before they're used. You might think this would make structuring Python code hard because the order of functions needs to be just right. As it turns out, there's a simple trick that makes this super easy. Most Python developers solve this problem by defining all the functions in their program first, then finally calling the entry point function last. Conventionally, the entry point function is usually called main to keep things simple and consistent. If you follow this pattern, you can forget about ordering. All of the functions have been read by Python interpreter before the first one is called. Yep. Functions must be defined before they can be called. Functions must be defined in the same order they call one another. False. Which is the best practice. Make sure you don't define functions out of order. Yeah. That one. Okay, how long have we've been going for? Like 45 minutes. There's really not much left I can do on Boot.Dev without paying for it, so I'm probably gonna stop here because, frankly, I also think this isn't too interesting to watch. But, sure. This forced me to look at Boot.Dev more, which is kind of why I stream this. It's less so for, the viewer's entertainment and more so to force me to do my work. So I'm going to try next week. I'm going to start learning Game Maker Studio. So we're going to do that probably on Tuesday. And yeah, so we'll actually try to make something not super complex, but a game next week. Just like my Python, not Python, Godot stream a few weeks ago. It's like we tried to make Flappy Bird in Godot. It's going to be about that level. Not starting any massive overarching game projects because I still need to learn all this stuff. But we'll get there. Be sure tune in to the podcast tonight. Me and Eli, we got some fun things to talk about, and it'll be a heck of a lot more interesting than this. And if you want to watch me code, come back next Tuesday. We'll be doing the same thing, except I'll actually try to make something. If you're not interested in coding, we're back to playing games tomorrow. I believe I'm doing another Crab's Treasure. I will start posting my schedule on YouTube as well. I will remember to do that. So, yeah, but that's about all. Thank you all so much for hanging out with me while I did nothing. But that'll be all. Have a great rest of your day. I'll catch you later.